And Wellman, I'm passing on the microphone to Dieter. I'm passing on the microphone to you. Thank you.
Okay. Thank you, Godwin. Hello, everybody, and thank you very much for joining us today on this webinar. In my opinion, we have some very interesting topics which we will cover today, and I'm very happy that we could get two very experienced and renowned experts for this webinar. But please allow me to introduce myself and our company a little bit before we start with the first part of the technical webinar. My name is Dieter Wellman. I'm a product manager here at Comtech for signal management solutions, pre-sales and after-sales support, and many other things. And I have been at Comtech for 3 years now, and I myself, I have an IT background. So before joining Comtech, I worked as an IT specialist at several companies, for example, in the telecommunication and insurance sector. But I was also working with audio and video technologies. For the few among you who don't know us very well, Comtech has been a successful distributor in the AV market for almost 30 years, and meanwhile we are one of the largest distributors for professional AV products in Europe, and we are still growing. And speaking of growing, Comtech has local companies and distribution sites in every country in Europe, and since May 2013, the international operations have extended into Asia with a subsidiary based in Hong Kong. So it's no wonder that we won the distributor award for the fastest growing distributor. So here you can see a quick overview of our large product portfolio, which can be generally divided into 4 main areas. We have many well-known brands in our portfolio, but it would take way too long to mention them now. So I would say let's go over to the introduction of the speakers who will present today's webinar. We will start with Ariel Marcus from Valens Semiconductor. Valens created the HD-BaseT standard in 2010, and Ariel Marcus has more than 19 years of experience in product development, customer support, and system integration. And as a director for customer experience at Valens, Ariel is deeply involved in day-to-day interactions with customers. And prior to this role, Ariel managed the customer support team at Valens. And before joining Valens, Ariel led product development teams at Infineon and Spansion. The second part will be presented by Paul Kish from Belden Incorporated. And this is an American manufacturer of networking, connectivity, and cable products, and they are one of the largest cable manufacturers in the world. Paul Kish is the Director of Systems and Standards at Belden. He's a key contributor to the development of cabling standards since 1989 with committees like TIA, ISO, IEC, and IEEE. Paul Kish also serves on the Big C Technical Information and Methods Committee as a subject matter expert on the principles of transmission. And Paul has authored many technical papers that have been published in various industry magazines and technical conferences. And he's also presented seminars at Big C and other industry forums to promote cabling standards and the need for higher performance cabling. Now, before I hand over to Ariel Marcus, I would like to explain the reason why we set up this webinar at all. We at Comtech have been selling HD-BaseT products for some time, and I discovered that many of our customers didn't understand the principle of HD-BaseT. They often confuse it with Ethernet, since both use the same cable and connector types. So they didn't know the requirements of HD-BaseT regarding cabling, connectors, etc. And even until today, there's a lot of mystery about the required type of cabling, especially for supporting 4K applications over HD-BaseT. And here you see a short list of what some vendors are saying, and sometimes such statements, which you can see here, are rather confusing than helping. So we could have called this webinar maybe HD-BaseT demystified, because I think we will clear up with some of the false or misleading information which is circulating out there. Okay, all right, let's get started, and I'm pleased to hand over to Ariel Marcus from Valens Semiconductor, and Godwin will now switch over to Ariel's presentation in Israel, and this might take a second or two. I would like to say thank you on my behalf, and have fun with the first part of the technical webinar. Thank you.
Hi everybody, and thank you, Dieter. As Dieter mentioned, my name is Ariel Marcos. I'm from Valence. I'm located in Israel, and I'm representing the HD-Base on many occasions. We will go on this seminar. I'd like to focus a little bit more about the cabling and about using the termination, cable bundling. What is HD-Base? We will go about the link structure, what are the different new classes that we have, and we will go in general about the new features provided in HD-Base 2.0, assuming that you are already familiar with HD-Base 1.0. We will go a little bit about the installer zone, a new location that you can find a lot of information about products and about searching for new products. We will introduce also the new app that you have for Android and iOS provided by the HD-Base Alliance, also to examine and find products that fit the needs that you have for different features. So we will start first of all, what is HD-Base? As you are already familiar, most of those cables are the one that you need to connect in order to have and transmit HD video. You need those audio, USB, and all of those. So HD-Base is actually a new standard of digital connectivity on the ultimate cable, which is the category cables that you are very familiar with. Let's go now a little bit inside what is HD-Base. So it's actually providing the best possible user experience for a variety of time-sensitive applications over low-cost infrastructure cable. So HD-Base, as you can see here, is structured link, full duplex, asymmetric one. And it's very important to remember that it is an asymmetric one. As you already know, we are talking about up to 100 meter of category cable. HD-Base define 90 meter of infrastructure cable going through the walls and 2 patch cable of 5 meter each. We're talking about UTP, FTP, STP cables, all the difference that you are familiar. Main link is going over 4 pairs of 250 mega symbol or 500 mega symbol. This is the main link going from source to sink, carrying the video. It's using PAM16 symbol per second. Auxiliary channel, which is actually returning control and Ethernet, going also through 4 pairs of 12.5 mega symbol, PAM16 symbol. This way, we're able to conduct it as less sensitive to error caused by electrical wire effect, and it's optimizing the bandwidth that we're using. Now for the HD-Base 2.0. HD-Base 2.0 added additional features, and as so, we remain with the main link of 4 pairs with 250 mega symbols or 500 mega symbols using the PAM16, but on the auxiliary channel, we increase it to 4 channels of 25 meg symbols using PAM16. This is actually a little bit information and showing how the PAM16 is actually seen. This is how on the right side you will see actually on the line, transmission line, how it looks. And on the left side, this is what actually being optimized once again after 100 meters. You need to remember HD-Base is not an Ethernet. Ethernet today supports a maximum of 9 of PAM9 for the different transmissions, and if you cut the lines of the HD-Base you won't see Ethernet packets. Today, with the HD-Base 2.0, we introduce 3 new classes of HD-Base. There are 2 classes, class A and B, which are HD-Base-T, which support HD-Base-T 2.0 and 1.0, with a different range of 4K over 70 meter and 1080p up to 100 meter. It can go over category 5 with different limitations. Class B is actually 1080p with 70 meter and 4K with 35 meters. Class C is a new one going through 100 meter also for 4K. It depends, 100 meter or 90 meter, depend on the cable itself. Class D, which is limited to 30 meters only. And Class E is a totally new implementation, which is HD-Base-T over fiber. We have some good experience with several of the vendors, increasing, for example, SFRs and the fiber implementation, which were limited to original design for 300 meter. HD-Base-T improve it and can go up, for example, to 800 meters, more than double. HD-Base-T. It's important to remember HD-Base-T is limited by pixel clock rate and not by resolution. And that's very important to remember. HD-Base-T support up to 300 megapixel clock, and all the ultra 4K resolutions are actually going into this range with 297 megapixel clock. About the termination, let's talk a little bit about that. HD-Base-T support TIA 568A and B. It knows how to resolve crossover, semi-crossover, and straight connectivity. All of those are actually done automatically, and the HD-Base-T knows how to connect it, crimping the cable, going through the example which is shown here. HD-Base-T categories. HD-Base-T recommendation are as follows. We're using a 90 meter infrastructure cable, 2 patches of 5 meters on each side. Infrastructure cables should be at least 24 gauge or better than that. The minimum requirement for cabling is Cat 5e or better. Today we know that with the HD-Base-T 2.0 we recommend going directly to Cat 6a and not less. Any of the following cables will also fit: UTP, STP, SUTP, SSTP, all of those type HD-Base-T can handle and carry. One important thing that I would like to talk about now is the cable termination. There are several HD-Base-T, even though it looks like an Ethernet implementation, it is not. At the moment, the HD-Base-T is a point-to-point, and as so, we're dealing with several different type of implementation. One of them is floating power supplies. Floating power supplies, which each side is being fed without a chassis connectivity, and for that we will recommend connecting the cable shield on one end of the cable due to the differential voltage developed between the two sides, which are not being held, which are not grounded actually. Okay, now we can go also for a PoE implementation. We recommend to connect the shield on both ends since it will balance the power between them. Chassis ground. If both sides are chassis ground terminated, terminate the shield on both of them. If one side is a chassis ground and the other one is floating, then we recommend to connect the shield on the chassis termination side. Recommended cables for bundling. We have here an example for 3 different types of cables that we would recommend to use for the HD-Base-T in case you're using a bundle of cables. The first one is UTP. Cat6a. Then we can go to foil UTP and SFTP cables of category 7, class F, or category 6A in both cases. The testing, we recommend for the cable bundling to use mostly the Cat6A as the minimum. We do not, we recommend for the first 20 meters not to comb or pine strip the cables. Separate path and equipment cords. Avoid tie wraps. Use horizontal wire management techniques. Loosely place cable in vertical wire management. Reduce maximum conduity field density to 40%. Implementation of this practice is not required for augmented Cat6a FUTP, sometimes referred to as CTP, or Cat7. This practice do not need to be applied when using augmented Cat6a UTP system, such as those with cable diameter design enhancement that increase cable-to-cable separations. Okay, now I know that we went a little bit quickly about those topics, and I will be happy to answer some questions that you will have in a later state, because we don't have enough time to cover it all at the same. I would like to go with you about the HD-Base-T 5-play. HD-Base-T 2.0 present a new feature going into the 5-play convergency of single cable. We have audio and video, we have the Ethernet, we have the power driving, PoE or POH, we have the control system, and we have a new feature which is the USB. As you are all familiar, uncompressed Ultra HD audio and video, 100 Base-T Ethernet remain the same as in HD-Base-T 1.0. USB 2.0 is the new partner. Control signals like IR, CEC, RS-232. Power over HD-Base-T, which is actually the 100 watt. So what is actually the new parts? New parts in HD-Base-T 2.0 comparing to 1.0 is to have a native infrared interface for both HD-Base-T infrared type A and type B. We have a native RS-232 interface. We introduce two new audio interfaces, SPDIF and I2S, and we introduce the USB 2.0. CIR type A. CIR type A, the IR data is passing over the HD-Base-T without the carrier. Carrier is being filtered out, and we have only the baseband signal going through the system. This means that the remote side should know before transmitting the IR, he should know how to enable once again the carrier signal and add it to the signal in order to transmit it over the air. This is an important part that you need to verify with the vendor of the products that this can be achieved. When you're doing an integration between two products, receiver from one customer and transmitter from additional customer, you need to verify those. Then we have the CIR, consumer IR type B. Type B is actually carrier plus data are being passed over the HD-Base-T link. In this case, we support up to 60 kilohertz signal of the carrier. IR receive deliver the signal to the HD-Base-T link, including the modulation. IR light emitter will get this signal, and it should not add the carrier once again. So when you're using this type, you need to verify carefully that the IR transmitter that you are using on the remote side is not adding the carrier. Control signal. As you remember, again, we have the same RS-232. HDBaseT support only 3 pins connectivity: transmit data, receive data, and GND, which is not actually a signal, but this is what you need to connect over the RS-232 extending in the HDBaseT signal. There are manufacturers that implement a full RS-232 with a DTX, RTS, and all of those signals. This is a proprietary implementation, and it is working well. It can be done. What is actually, and now I'll go to the benefit that RS-232 over the HDBaseT 2.0 that you will see soon on the market. The HDBaseT 2.0 introduced a new capability of pre-configured RS-232. This means that manufacturers can define exactly what will be the baud rate that will go through the HDBaseT, and only that baud rate will pass and will be able to transmit over the HDBaseT. So you need to be very careful and consult your providers with the information about the RS-232 and how they define it. RS-232 in this structure can go up to 150 kilobit per second. That's the maximum limits for the HDBaseT. This one will go also in a low power state and in a full HDBaseT mode. HDBaseT 2.0 presents a new audio channel, which is the SPDIF. SPDIF is a digital audio format used for consumer audio equipment. The SPDIF can be transferred over either coaxial cable using an RCA connector or through a fiber optic using the Toslink. SPDIF can transfer audio with sample rate up to 192 kilohertz. This is, again, a vendor depend, meaning vendor can reduce the sample rate of this SPDIF, and you need to consult your vendors what type of SPDIF they are passing. There is an option of also for a variety of sampling rate that they can provide. Those are in the addition to audio embedded in the HDMI stream. Okay, it's not instead of, it's in addition to. It supports the use of the HDMI audio return channel, the ARC implementation. So this is new for the HDBaseT 2.0. In addition, the HDBaseT 2.0 introduced the I2S. I2S is commonly, it's a digital implementation of audio channel. It's commonly served for headset and microphones. It consists of 3 serial lines. HDBaseT 2.0 limits the maximum clock rate for the audio of the I2S to 5 megahertz. This is the limitation that we provide. These limitations covers most of the implementation available on the market today. There are some I2S implementation that will consume more than 5 megahertz, but those are very rare and you cannot find it you cannot find it at all. So 5 megahertz, based on what we have today, can cover most of the formats that you are aware and you are using these days. USB. USB is a new features riding on top of the HDBaseT. It is full USB 2.0 compliant. Many tests we've done with different labs over the world, like Elion and more. It supports asynchronous and synchronous devices like webcams, disk drive, HID, human interface devices, mouse, keyboards, disk on key, or whatever. All of those are supported. The HD-Base can support maximum of 7 devices, not more than that, and it has a guaranteed bandwidth over the HD-Base. But again, guaranteed bandwidth is okay, but the limitation is no more than 7 devices, and that's important to remember. Power over Ethernet or power over HD-Base. HD-Base introduced the POH. POH is actually delivering 100 watt over the category cable, and this goes into compatibility with IEEE standard for PoE. POH become a new class on this IEEE standard. It supports an input power of 44 to 57 volt DC, which comply with all the electrical regulation around the world, as it is the same implementation of PoE. It's even used the same negotiation layer of PoE. Device of a POH, while interfacing a device that supports PoE, will settle the power delivered to the remote side based on the lower common level that both can support. Means if we're using a PD device of 15 watt connected to a PSE, which is power source emitter of POH for 100 watt, after the negotiation layer, they will settle, and the definition for the PSE will be to provide only the 15 watt. So there is no dangerous in that. POH initiates 4 pairs of the category cable. This is the difference between POH and PoE. Most PoE will use only 2 pairs, A and C, for delivering the power, and the POH will deliver it on top of all 4 of them. This power can easily drive TVs of 16-inch and less. More than 16-inch at the moment will consume more power. There are several ways to manage it, but this is not for this session. Interoperability. As mentioned, POH initiates 4 pairs driving the high power. POH is defined as class of the PoE. POH is fully interoperable with PoE. Any power type driven on the HD-Base category cable which doesn't comply with IEEE PoE requirement is violating the HD-Base spec, and this is very important to remember. There are many products on the market which drive pure DC without being managed as a PoE. All of those products are violating the HD-Base spec, and we are well aware on the HD-Base Alliance, and many manufacturers are actually moving to use PoE to avoid damage or any interoperability issue with third parties. Now I would like to go with you a little bit about a new form of that the HD-Base Alliance provide, which is the installer zone. The target is to provide you a website that will answer questions and will provide you information about the different product of the HD-Base. We have an expert program on this website. The expert program contains 9 lessons, and finish those and going through all of those lessons will provide you an HD-Base expert certification that will be sent to you. You will gain also 1.RU for the InfoComm program. We have additional installer forum that we initiated. The installer forum came in order so that you can share between you information about installation, about issues that you're seeing, about solutions that you have found in order to overcome issues that you deal with. And it provides you also a link to me and to a team here that will answer questions that you will raise regarding the HD-Base T. Additionally, you have a mechanism that will allow you to select products that are HD-Base certified, and you will be able to see all the products and how they are actually certified. What features can be supported and cannot. One important thing that I think I forgot to mention is that even though the HD-Base consists of the 5-play, and the 5-play is part of it, not all the features should be supported with the HD-Base product that you are getting. There are products, for example, that will be HD-Base certified, but they will not support the infrared. There will be products that will be HD-Base certified, but they will not support the USB. Means that the USB will not go through that link. So it is important to understand HD-Base is a standard, it is a protocol, but not all the features are mandatory in order to be an HD-Base certified. As I mentioned, on the website, you will find an engine that will provide you the ability to search the product that you need based on different criteria that you will provide, like if you need an IR or you need an IR transmitter on the receiver side or IR receiver on the transmitter side. It depends all the configuration. It will provide you an easy way to obtain the product. It will provide you also a direct link to the manufacturer to see the data sheet and the specification for the specific product. So the website, by the way, requiring registration. This registration will serve us as the HD-Base Alliance in order to update you on new feature and new information regarding the HD-Base. So it's really important, and I do recommend using that website, registering for the HD-Base Alliance, and be updated with the most updated information and releases of the HD-Base. The installer forum, as I mentioned, require registration, and you can share and you can upload and update and raise many questions that you have and share information between you. Also, you can direct questions to me or to the team here that will answer the different and will try to resolve difficulties that you're seeing. A new thing that we just launched at the latest InfoComm in Orlando is the HD-Base app. There is an app at the moment. Again, it will provide you the ability to search for products which are certified based on the copper, fiber, IR, RS-232, USB, or whatever feature that you need. It will also provide a new way of experiencing and verifying the product that you need to install. The HD-Base Alliance set also a QR code. This QR code will be implemented on all HD-Base packaging, which will be distributed. Those HD-Base logo will carry those Q code, and by pointing the camera of the mobile device to this Q code, you immediately will get a link to the product. You will see for what it is certified, what are the certifications that it passes, and will be able to provide you immediate information about the product itself. So this is also recommended. You can go to the Google App Store and the Apple App Store and download this application and try it. It's already available. That's it for me now. I will be happy to pass the presentation to Paul. Paul, you're with us?
Yes, I will. Yes, Paul is here as well, and I will make Paul the presenter so that we will also be able to see his screen and he will do his presentation. If you have any questions regarding this presentation, which is Ariel just delivered, please write them in the questions pane, and then at the end we will take care of all of them. So don't hesitate to do that. I will now make Paul the presenter. And so, Paul, you are now presenter, so please show us your screen.
Can you see it all right?
Oh, yes, I can see it now. So it's now you've got the floor.
Okay, thank you very much, Ariel. It was a very interesting and informative presentation. A lot of good information. So the information I'll be presenting will be complementing some of the information that's been presented so far, but more focusing on cabling and some of the differences and capabilities between HDMI and HD-Base-T standards. So these are the main items we'll be covering: a brief look at HDMI and HD-Base-T, the bandwidth required to support 4K video for different formats, and some of the issues that HD-Base-T resolves that are there with HDMI. Then look at different ways of deploying HD-Base-T over balanced twisted pair cabling. So there are different configurations of cabling that can be used in the field, and just wanted to highlight those and the information related to choosing and installing the cabling system components and how to verify the quality of the cabling installation. The last part of the presentation deals with some testing that we've performed at Belden in our systems lab relating to how HD-Base-T systems perform in worst-case bundling configurations, different categories of cabling. So present those results and some of the data that we've identified in terms of how it correlates with 10G-Base-T in terms of alien crosstalk margin computation. So it's an interesting aspect of it, and followed by a brief summary. So looking at HDMI and HD-Base-T, they're both standards. Well, they're developed by a forum or a manufacturer's group. In the case of HDMI, it's the HDMI forum, and they have a website, hdmi.org. And it was the standards and different versions of them, the specs were introduced in 2002. HD-Base-T as a network technology was introduced in 2010, started as HD-Base-T 1.0, and we've heard about all the features that are available in HD-Base-T 2.0. The difference is that the HD-Base-T allows you to transport information all at these video and audio and all the various other types of information up to distances of 100 meters over balanced twisted pair cabling with modular RJ45 connectors. So the same type of data cable that's used for Ethernet is used for HD-Base-T. So 4K video, it's the latest buzzword in the industry and the consumer market and for the next generation video display that will deliver a whole new level of resolution, up to 4 times the resolution of full HD, which is commonly known as 1080p. So the TV set manufacturers, Samsung, LG, Sony, Panasonic, are already selling 4K TV sets. And there's a research report by ABI Research that expects that by 2018, at least in North America, 10% of households will have the ability to view video at 4K resolutions. So when we talk about 4K, this diagram here illustrates the resolution comparing 480p, 720p, 1080p, which is high definition, Ultra HD, which is 4 times in terms of the resolution number of pixels, high and wide, compared to 1080p. And then there's also 4K DCI, which is the digital cinema standard, and that's a bit wider, and it's 4096 by 2160. So when we talk about 4K in the professional world, they relate to the DCI standard, and for the 16:9 displays that people are currently using with 1080p, Ultra HD provides 4 times that resolution. So let's look at what the bandwidth is needed to support 4K video. Ariel had mentioned in his presentation that it's limited by the clock rate to 300 megahertz about, and for HD-Base-T. So let's look at what type of formats can be supported over that in terms of HDMI as well as HD-Base-T. So in this particular table, I've summarized the different versions of the HDMI spec 1.3, 1.4, and 2.0. So HD-Base-T, at least today, corresponds to the HDMI 1.4 spec in terms of bandwidth and the pixel clock rate. Slightly higher for HDMI 340, but in terms of equivalence, they're equivalent. The maximum data throughput in gigabits per second is 10.2 gigabits per second, and for HDMI 2.0 it's 18 gigabits per second. The important thing to remember is that because of the encoding system that's used, 10.2 gigabits per second on HDMI corresponds to about 8 gigabits per second on HD-Base-T, so that's where the equivalence is. HD-Base-T is a more efficient encoding scheme. The key thing here I wanted to present on this slide is what's highlighted in red. So what is the maximum resolution that is supported? So HDMI 1.4 does support 4K, but at a frame rate of 30 frames per second. That's what the P30 means. And for 3D video, where you have, each eye sees video images, you're not capable of supporting, at least today, for the 4K resolution. When they've introduced the HDMI 2.0 spec, because of the higher data rate, they can support 4K at 60 frames per second, and also 3D at 24 frames per second. The other thing to note is that the digital cinema, the DVDs that you would look at, or the Blu-rays, typically they record at 24 frames per second. So it's not a big limitation. So the next part I wanted to look at is some ways of how one can look at the bandwidth and utilize it more efficiently for transmitting video information. So if we look at a color picture, and this is a picture representing one frame, you can take this color picture and resolve it into the 3 primary colors, red, green, and blue. And then from there, there's a further way of looking at it, which is more actually useful for the way that the color information is used, is to record the light intensity or the luminance information, which is shown by the coordinate Y, and then chroma R and chroma B, CR and CB. That's the difference in the intensity of the red signal compared to the green signal, or the blue signal compared to the green. So it looks at the differences between the two, and essentially represents the color information in an equivalent way. Now the reason to do that is kind of shown on this slide, and it's looking at the chroma subsampling. So if we have, each square represents a pixel. So each pixel can contain the Y information for the luma and the chroma information, the red and the blue. So this now is all the information per pixel is fully transmitted. Another way of it, it is known that the eye is more sensitive to light information than it is to color. It doesn't resolve very well the motion or position of the color information. So you could trade off the actual bandwidth that you need by only putting the color information, for example, on the 422 on one pixel and leaving the color out on the other pixel. So the actual decoding will, implement the color in the other one based on the averaging of the ones that contain the color. And another common one, that reduces the bandwidth required to about 2/3. And 420 is the bandwidth is about 1/2, and the color information is actually spread out over 4 pixels. So and it's significantly, and 420 is what's frequently used in MPEG encoding schemes, including what's commonly transmitted on Blu-ray, DVDs, etc. So it does reduce the bandwidth requirements significantly. So if we look at the HDMI 2.0 specifications, there's the other dimension here on the top here, which is the number of bits per color. So 8-bit color provides you, 8 bits per color. Some implementations may want a larger color depth, so you can go with 10-bit, 12-bit. Every time you do that, you also increase the bandwidth requirements. But looking at what's shown in the red square, HDMI 2.0 does support 4K at 60 hertz frame rate with full 444 resolution. But if you're going to, say, example, 12-bit color depth, you're limited now only to 422 or 420. And for 16-bit, which is the highest one, is 420. So that's some information to look at in terms of, like, when you see these values reported in terms of the support for the 4K, to kind of understand what's being discussed. Now, the issues with HDMI is that it's very limited in terms of the cable distance that it can support, usually no longer than 5 meters, and with special cables you might be able to go to 15 meters. It's not a configuration that can easily be installed like compared to RJ45. So if you plug in directly with an HDMI connector, it can be disconnected by moving the cable. There's no way of terminating the HDMI connector in the field. Difficult to pass through conduits. It's bulky and the connectors. And the actual cables themselves, the certification of the cable requires specialized equipment. So currently it's Category 1 and Category 2 certified as high speed that are tested using an eye diagram to show that it can support these higher resolutions, either a full HD or Ultra HD. So HDBaseT resolves these issues. The spec was the first HDBaseT 2.0 was published in August 2013. Currently supports the HDMI 1.4 spec, provides a maximum throughput of 8 gigabits, which I had mentioned is equivalent to 10.2 for the HDMI 1.4 spec. The current version as well, HDBaseT 2.0, supports the 5-play and provides an upstream data signal of up to 300 megabits per second to support return audio, Ethernet, and control information. This particular chart is one vendor's equipment that is available for HDBaseT to support 4K, which is a chart that I took off online from their specifications. So it basically indicates the resolution that are able to support and the frame rate. So For 4K, we have and 444, which is the full color sampling, no loss of color information, up to 24 hertz or 30 hertz frame rate, and up to 60 hertz, which is a better picture because it removes the flickering, and with some type of sources, but it can go with 420, which is a slight loss of color, but not noticeable generally when you're looking at it for most people. So the next part I wanted to quickly, I'll go through the different ways of deploying HD-Base-T over balanced twisted pair cabling. So this diagram here illustrates the top two configurations are a common way that it's installed for data circuits, and so it basically on the right-hand side we have the jack termination and the patch panel in the telecom room connected to the equipment, and on the left-hand side is the jack termination at the equipment outlet. So the advantage of using these configurations is that it allows you to plug in different equipment using patch cords at either end. So it's more flexible in terms of rearrangements. The second one is essentially a pre-terminated type cable, which has, it's a plug-and-play approach using couplers at both ends. So that makes it simple, and it's not subject to installation variables sometimes in terms of installing cables and punching them down. And the third is the direct attach, which I'll be speaking a little bit more at. So we'll take a horizontal cable and we'll terminate a plug on it and plug it directly to the equipment at either end. So these RJ45 plugs can be either terminated in the factory if it's a known length, or terminated in the field on regular horizontal cabling. And I'll show you some pictures that shows how these plugs, what type of plugs are recommended and how they are installed. So the installation using a jack or a coupler can be easily tested using a permanent link test for the category of performance. This is commonly done in the field and provides an indication of the quality of the installation and of the cabling system. So in our recommendation, this is what we recommend in terms of testing it. And even for the direct attach scenario, we provide a way of testing it as a permanent link. So again, looking at the direct attach again in a little bit more detail. So I'm going to focus on installation of that plug in the field. So it's quite important that the right quality and the right design of plug is used, so that when the wires are terminated inside the plug, the transmission performance of that connection is reliable but also stable and consistent, so that you don't deteriorate the quality of the crosstalk in that connection. So and how to actually verify it. So we have we recommend using a Cat6a field mount plug. This is one design that we recommend. We've tested it. The reason that it's better is that it's very well controlled, and it's not sensitive to installation variables, and makes it easy to terminate and gives you consistent performance. The actual transmission performance is controlled in terms of the printed circuit board that plugs into the plug and is becomes independent of the position of the wires. So it does give a very consistent performance, available in both shielded and UTP versions. And this is an illustration of how the field, the plug is terminated in the field. So in this case here, we're showing a shielded type, individually shielded pair with an overall braid type construction. So you separate out the pairs, you thread them through the actual inserts that are color-coded. You crimp down the connect so that makes contact with the wire. You remove the excess wire. You wind the braid or the drain wire around the cable, and then you insert that into the plug shell, the body of the shell. You clamp it down on the shield, and it gives you the connection. It gives you a good connection every time. Now, in terms of how you test this direct attached link, so we see the same testers as we have before with a permanent link adapter. The test adapter has a controlled plug that meets the requirements of the category specification, and it connects to a coupler at one end, and the other end connects directly to the direct attached cabling. So we test it through these couplers. These couplers are designed so that they meet category 6A requirements with an RJ45 plug connected at each end, so that we are confident in terms of the performance of that connection. If there's a problem with that modular plug, it'll show up as not meeting 6A requirements when tested as a permanent link. Next part of the presentation, I'll look at some of the multi-disturber testing that we did. The main reason that we've done this work is because some of our partners have experienced issues with multiple cables, HDBaseT signals in separate cables that shared the same pathways, and sometimes you get a degraded or total loss of signal. So we wanted to determine under what conditions this might occur. So this is a description of the test setup. We used a quantum data signal generator that provided a test signal. In this particular case, it's a 1080p signal. The pixel rate is about 150 megahertz, and this signal is transmitted through an HDMI matrix switcher and through several HD-Base-T transmitter at one end and HD-Base-T receivers at the other end through another matrix switcher. The cable was bundled in what's known in the industry as a 6-around-1 cable bundling configuration. So the victim cable is in the center, and it's surrounded by 6 cables. That's the most that you can do, and then every 8 inches you bind the cables together, so it gives you a very worst-case configurations. Category 6A cables are tested in this particular mode and must meet certain alien crosstalk requirements for the 10G-Base-T application. So the results that we got when tested in this configuration, we found significant limitations in terms of Category 5E UTP cabling. In this worst case bundle, at most you could support about 10 meters, which is around 30 feet. If you went to a shielded Cat 5e or Cat 6, we went as high as 105 meters. It would fully support it. For Category 6 UTP, pre-terminated and direct attach would support up to 40 meters, and some field-terminated configurations only about 30 meters. Category 6A UTP, in whatever configuration we've tested it, it supports the full distance of 105 meters. So we wanted to understand whether there's a correlation between the results that we obtained using the system level tests with alien crosstalk requirements that are currently specified for 10G-Base-T. So in the same cable bundles, we tested for alien crosstalk, and we used Fluke Networks test equipment. This is ETX 1800, and you test essentially the crosstalk between these links on the victim channel, which is the one that was disturbed. And you do a power sum of all the alien near end and alien far end, and you compute what's called the alien crosstalk margin computation, ACMC. And it looks at the crosstalk in range of 10 megahertz to 400 megahertz, which is generally the range that's used for HD-Base-T as well, but maybe not as high as 400 megahertz, but it's within that range. And this is basically what we found. This happens to be for the Category 5E channel. When your ACMC provides a margin of 3 dB or better, it would work fine. When it's in the range between minus 3 dB, which is failing 10G-Base-T, to 0, sometimes it would pass, sometimes it would fail. And then below minus 3, it would always fail. So it is a good indicator. alien crosstalk is the issue in this specific case. And that's why, as we recommend the use of 6A or shielded Cat6 are better for this application. So these are a summary of our recommendations. In North America, primarily, we do use UTP cabling systems, so it should be 6A or better. And in the case of Belden, we have both shielded and unshielded 6A, and it's called the 10GX systems. But it'll also work on Category 6 FUTP and even Category 5E. But we recommend, as a minimum, a Cat6 because it performs well and is specified at these higher frequencies that the system uses. So the designation for our cabling solution in that area is 2400F for the foil shield. When using a shielded system also, it's critical to maintain shield integrity at all connection points to provide a low impedance path to ground. Now, I know in the presentation that Ariel presented, not all equipment is grounded, but it is internally grounded through the casing. So even if you're not grounding it externally at one end, it is important to use a shielded patch cord or to extend that shield through a shielded plug all the way to the equipment, which usually contains a shielded RJ45 connector. It's also important for EMI reasons as well, because some of these are rated in terms of Class A or Class B emissions, and it depends on the performance of it, having that shield present connection at the equipment. So in summary, we know that the audio-video market have moved to digital transmission. HDMI certainly has gained a lot of popularity in the industry, and it's over 3 billion devices that are currently used, mainly in the commercial and the consumer market. HD-Base T is a solution that resolves many of the issues with HDMI. If you want to go longer distances, it's the only way to do it effectively. And the key thing is that HD-Base T can support, will support a lot of the AV and HDMI capabilities, but it's important to install a good cabling system like Category 6A UTP or Category 6 shielded cabling. It should be noted that some vendors' equipment are even advocating using more performing cables, I guess is the way to say it, including shielded Category 6A or Category 7A to support 4K video. So for example, one of the quotations that was shown by Dieter showed that if you only use 6A, it might only go 70 meters instead of 100 meters. So we know that that is still to be verified, and more guidance is needed in this area. But based so far on the testing and some of the recommendations that I've seen today, as well from the HDMI Alliance, or I'm sorry, the HD-Base T Alliance, Category 6A, I think, would be the minimum recommendation. So thank you, everyone, for being part of this audience. Now we'll open it up for questions. We'll be online to answer any questions that you have. So Dieter, I don't know if you want to take it over from here.
This is Godwin will take over.
Yes, yes. Thank you very much, Ariel. Thank you very much, Paul. Obviously, thank you very much, Dieter. We have some chat going on the between the audience and some of the organizers, presenters. So if there are any questions, Paul and Ariel are going to be in the system for a little while, but I would like to use the system as I used it in the past, and I would like to read out the questions, and I would answer also I'll give the answers which have been given, so that there is also a record for the other participants in the webinar. So the first question is going to be, and please, if there are questions for Paul, just type them in and send them over, and then we will handle them. I know we're running over a little. It's 5 6 minutes after 5, so in my time, so it's in 6 minutes after the 1 hour. We'll try and make it as quickly as possible, so people in Europe will be able to enjoy their evening. Okay, the first question is, so concerning the maximum length of cables we can use. Now what's important is to be sure of HDBaseT class of products, and Ariel has answered, yes, this is all correct. So this is important. It's important to use the HDBaseT class of products. The other thing is, the question was put, I didn't understand the IR part. Is there a white paper to study for more detail? And the answer is that we'll publish a white paper on the IR and RS-232 on the installer zone, which was mentioned in the webinar. So that's the other question. Now there is a third question, which is, I know there's a category of HDMI extenders uses coax cables. They are careful when cables are blocked into conduit. No Cat 5.6 can be used in these cases. Does HDBaseT take note of this and has alternatives? The alternatives, the question is then put over again, is are we talking about the alternatives like HDBaseT over coax, which is then answered by the questionnaire somewhere else, I would guess. And it's yes, and the answer to that is yes, HDBaseT is looking for such alternatives, and it is already being tested these days. So there will be, apparently there will be alternative that HDBaseT would then be able to go over coax. There's another question, is what about the bandwidth of the cable? What is the minimum bandwidth to have a transmission over 100 meters of cable? Then we will need to... Can you answer that, please, Ariel?
I don't really understand exactly the question. So the bandwidth is limited. Okay, we know that we can go up to 10.2 to 10.2, and actually the HDBaseT is initiating 8.2 on the bandwidth. So if you can clarify a little bit more or be more specific, I don't really understand.
Okay. Well, the person who asked the question in the first place would need to elaborate a little bit more.
Maybe I can add a little bit of insight into this as well.
Yeah.
I know that, for example, depending on the encoding system, HDBaseT uses PAM16, 10G-baseT as well uses PAM16, but with some additional error-correcting coding built in. So if we compare the two, they're very comparable, 8 gigabits versus 10 gigabits. So 10G-baseT uses a bandwidth of 400 megahertz for the cabling, but specs up to 500 megahertz, which is where category 6A is spec. So I would say that the bandwidth of the cabling system to accommodate the full range of frequencies, whether it's HD-baseT or 10G-baseT, should be 500 megahertz as a minimum.
Okay, thank you very much, Paul, for that. The conversation about the coax went on a little bit, and it's saying, or better, is it possible to have all the services of Cat 5.6 cable using coax? Now, the answer to that is most services will be available, but since the bandwidth will be reduced, it will support lower resolution. And the question was, that means lower resolution, that means not 4K, and that is also correct. So coax will not be able to, and Ariel, if I'm saying something wrong here, please correct me if I'm wrong. Coax will not be able to support or pass 4K through. Correct. Okay, great. The next one is a question, is there any affordable hardware or software for diagnosis? Now the question here is, are there for diagnosis, I would expect that the questioner is asking for diagnosis on HDBaseT on the cabling. If that's not the case, then we would need to have the questioner specifying whether he is...
I think yes, this is Ariel. I think yes, if it's referring to the HD-Base-T, there is the quantum data that can do diagnostic for the HD-Base-T link.
If I may add something myself, we at Comtech were looking for affordable hardware for diagnostics for HD-Base-T as well, and I've been looking for quite some time. And the cheapest one I found was Quantum Data 780C, but it is not really cheap. It costs quite a sum. So if you really expect a low-end price diagnostics product, I haven't found it yet. But if anybody else knows something, I know, for example, Fluke has some diagnostics for 10G base T as well, but also costs even more than the Quantum Data. So I would say this is, in my opinion, the cheapest product, but still costs several thousands of euros. So I don't know what you think about that.
Okay, then I've got one question, which is, are the presentations available afterwards? To this, I have to say that the recording will be available, and we'll actually put it on YouTube. We will be able to get the presentation of Paul's presentation from Melbourne. Unfortunately, we will not be able to deliver the presentation which was done by Ariel. So in this case, if there are any questions to be asked which need to be, then I would guess that the website installer's side would be able to answer quite a lot of questions, and there will be also the Ariel's team at the back who will be able to answer any questions. So although the presentation per se is not available, information can be obtained directly from Valence from HD-Base-T. And I assume that Ariel is also conform with what I'm saying. Okay, can you tell us something about electromagnetic compatibility, emission and immunity of HD-Base-T devices and cables? Can it be used in the medical area?
Okay, this is Ariel. In the medical area, yes, those products are being used. The HD-Base-T is used, for example, for very short distance as a galvanic isolation, which is very important on the medical. As for the emission and immunity, yes, since those, you can pass them, but you need a specific implementation for it. I think this is a very big discussion can be over this. I don't think this is the time.
The right forum.
I can take it offline.
Okay.
Yeah.
Good. So, so in this case, it will be very specific to the installation which we are talking about, and then the answer will be specific to that, to that installation. Okay, that has been answered. So basically, there's another one. What about the minimum AWG of the patch cable? There is, I guess, this is something which Paul can answer.
Yeah, I can do that. There are two types that are both recognized in the standard. So one is 24 gauge and the other one's 26 gauge. So I would say the minimum is 26 gauge. The difference is the loss of the patch cord. So a 26 gauge patch cord has 50% more loss than the main cable, and 24 gauge patch cord has about 24% more loss than the cable. So using a smaller gauge patch cable will reduce your signal level, make it more susceptible to noise, but as long as you don't exceed 100 meters in the case of 24 gauge patch cords, or 98 meters, the equivalent with 26 gauge patch cords, it would be compliant. So you really reduce the distance only by 2 meters by using 26 gauge patch cords.
Excellent. Somebody's saying that audio is lost. I still have audio, so I think this is a local issue. Well, basically, we are finished. Now it's okay. Okay. So now we've come to the end of the questions we had for us. Obviously, the the persons behind this webinar are also still available. You have heard the names of the companies, you have heard the names of the people behind that. If there are any issues and you would like to get in touch with these people and you find difficulty locating them, please drop me a line. I'm at InfoComm in Munich, and my email address is gdemicoli@infocom.org. I'm the Regional Director of Europe. So if there are any issues with connecting to these people, I will be able to help you. We have come to the end of this webinar. I would like to thank very much Comtech for putting this also together. I'd like to thank obviously very much Ariel, and I would like to thank Paul very much for the very, very interesting presentations. I'm sure that there has been some information grasped and achieved by the listeners. To the listeners, thank you very, very much for participating in this webinar. I hope it has given you some new insight, and I hope it has demystified, as Dieter said in the beginning, HD-Base-T, and if there are any other issues, questions, you know where to go, at least in trying to get them answered. So please thank you very much. Please, all the participants, I would request to spare me the lot of work in taking them out of the system. I will stop the recording now.